Good afternoon, everyone. Hope you have a good lunch. My name is Tang Sunyap. I will be the chair of this session. And our first session for today is Big Data Carto, workflow for visualizing large data stream. ArcGIS provides an analytics framework to summarize, visualize, analyze patterns using large volume of data. Today, Hui Yi and me will take you on a tour of the tools such as Geoanalytics Server, ArcGIS Pro, that help you transform big data feeds into beautiful and informative maps. Hui is an enterprise web GIS specialist who enjoys working with Esri API products like Python, JavaScript, and Flex. Her background in geography drives her interest in utilizing GIS technology to develop geospatial solutions and help organizations achieve more effective spatial data management. As for myself, I'm actively involved in delivering solutions to government agencies, banks, and utility providers. So we get started. So I'll pass the mic to Hui.
Okay, welcome back everybody from lunch. As Tang said, I'm Hui, so we'll be going through this first session of the technical sessions today. Big data cartography, workflows for visualizing large data streams. So what are we going to be looking at today? Essentially, we're going to look at what is big data, what is spatial analysis, how do you marry those two together. Now, of course, the whole idea behind this is to what kind of visualization workflows you will have. You could have with the platform, and of course, we'll take any questions at the end of it. So let's get started. Now, data is everywhere, and it's obviously growing. So how are you going to measure big data? Big data typically is defined as something that's humongous volumes of data, be it structured, unstructured, that cannot be processed effectively with your traditional applications that currently exist. So now the processing of big data begins with the raw data that isn't aggregated and is most often impossible to store in the memory of a single computer. You are looking at volume and scale. It is estimated that 90% of today's data has been created in just the past 2 years, with 2.5 quintillion bytes of data created daily. You're also looking at the velocity or speed of the data. So it's estimated that every minute, about 72 hours of video footage is uploaded on YouTube at any time. You're also looking at the variety of data. About 90% of data is unstructured, coming in the form of tweets, photos, videos, and the like. Now, of course, with so much data, there's an idea of what they call veracity, where about 1 in 3 business leaders actually do not really trust the information as they're uncertain about the quality of the data that's coming in. However, although it seems daunting, mastering big data will actually give you the ability to achieve the most important 5th V, which is to gain superior value by running analytics on data at higher volumes, velocities, varieties, or veracities. Now, with higher data volumes, you can actually take a more holistic view of your subject's past, present, and likely future. And at higher data velocities, you can actually ground your decisions in continuously updated real-time data. With the broader variety of data that's coming in, you can actually have a more nuanced view of the matter that is happening at hand. And of course, as data veracity improves, you can actually be more confident that you're working with the truest, cleanest, and most consistent data. So now the whole objective of today's session, and of course in analyzing any kind of big data, is to achieve the 5th V and to make it as simple to understand as possible so that you can actually gain maximum value. So actually, what does all this have to do with GIS? Now, GIS can actually help transform your big data into big insights by providing tools to understanding. And how does this work? Because it gives you actually a spatial and temporal context to your data. It also provides you with tools to do measuring, providing geometry to your data, which actually involves shape, size, and distribution of the information. It also helps you to understand and determine how places are related in terms of proximity, whether anything is overlapping, what kind of visibility you have, and accessibility. And of course, it gives you tools to actually find the best locations and paths. For instance, the shortest path from point A to point B. And of course, GIS also can help you to detect and quantify finding hotspots, any kind of outliers, or finding natural data clusters, and actually enables you to analyze changes over time. And lastly, spatial analysis actually lets you use powerful modeling techniques to make predictions and explore future scenarios. So, in that case, what is spatial analysis? And what kind of analysis workflows can you perform with big data? Now, essentially, spatial analysis, the basis of it is the process of examining locations, attributes, relationships of features in spatial data through analytical techniques that will actually help you address a question so that you can gain useful knowledge. So essentially, you can use it in human geography or physical geography, if you actually remember your geography. So you can actually do things like crime studies, where you have a lot of crime that's happening over so many years. You can actually analyze patterns, or you can actually do it in the physical realm, where you can do climate change analysis, which is on the minds of a lot of people right now. So now, like what I was saying just now, how do you actually marry big data analysis and spatial analysis? If you take a look at it, if you take a step back, essentially spatial analysis, this is the typical workflow that you will usually follow. You first of all identify a problem. You prepare your data, find your data, and of course perform the analysis. Once the analysis result comes out, you actually review, style the result so that it's actually easier for your users to interpret what you're trying to tell them. And of course, once all that is done, you actually share the information or repeat your analysis all over again. You'll find that we bring this up because this entire workflow, it is the same, regardless of the size of your data. It can be a smaller size data or big data, like all the 4 Vs that we were talking about just now. So, what kinds of out-of-the-box big data analysis and visualization workflows do you have access to with the ArcGIS platform? Now, with the ArcGIS platform, spatial analysis capabilities at scale come with tools from the Geoanalytics Server. With this, you actually have distributed processing capabilities, which will use large spatial temporal vector and tabular data sets. Or you can actually be working with GeoEvent Server, which will actually let you ingest real-time data, run real-time analysis, and of course, archive and disseminate the data. You could also be working with Image Server. This again will give you distributed processing of large raster datasets, be it imagery or rasters, through raster analytics. So for today's session, we'll actually be focusing on the Geoanalytics Server. With the out-of-the-box platform tools, you actually gain the capability to move from noise to intelligence, thus fulfilling your 5th V, which, if you remember, is to try to gain superior value out of your data. Now, your out-of-the-box tools include things like summarizing data, analyze patterns, finding locations, managing your data, and of course, using proximity tools. So what you'll notice actually is that I have a little legend at the side. I hope you can see it. So essentially, all of these tools are now available to you out of the box from the platform. And all those in white were actually introduced first at version 10.5, 10.5.1 of the ArcGIS platform. With version 10.6, more tools were added to the platform so that it makes your analysis workflow and visualization workflow easier. And those in green actually are what were introduced at 10.6.1, which actually came out in July. So you actually have a lot of tools available at your fingertips. What we essentially want from big data spatial analysis and visualization is to gain insights and to move from noise to intelligence, like I was saying. What you are looking at is actually about 170 million taxi pickup points in New York City. As you can see, you can't really tell much. They are just dots. There isn't really any kind of pattern in it. What we want to do is essentially to simplify the data. We want to look at real patterns and trends by aggregating into polygons so that you can actually gain more information from the patterns itself. And how do we actually do this? We do this by understanding change over space, time, and scale. So one way of actually using an aggregation workflow when you're working with big data spatial analysis is actually to do what we call aggregation, summarizing your data into understandable chunks. where you can actually summarize by space, by time, or out of the box, using a combination of both at once. Now, the time component itself can actually be broken down further into these different things. You essentially are given 3 additional parameters to actually define time steps. One is interval. You can actually define the duration of time that you want to do. Is it 1 minute, every 1 hour, every 10 hours, etc.? You can also choose to repeat the frequency of the time step. Now, of course, you can set a reference time. So what do I mean by that? So to just give you some examples, if I want to do an hourly time step, I just set it to an interval of an hour. If I want to run the analysis for an hour but repeat it every 12 hours, I can do that as well. Or I can even set it to reference a specific time, which is to run that same 1 hour interval every week, but to get it to start at a certain Monday. So with all that background, right, what we are going to do now is to actually try to take you through a demonstration of shipping patterns analysis. We're going to take a look at the maritime space today. Why? Because onboard ship and other sensors are actually constantly collecting information. It's on all aspects of the ship. It also can be collecting information on environmental conditions like wave heights, weather fronts, etc. Now what happens is that there is what we call an automated identification system, or an AIS, which are required to be installed on vessels that are longer than 30 meters. And these actually constantly broadcast data about a vessel every few minutes. So you are actually going to get more than 250,000 vessels broadcasting their location globally throughout each single day. So if you remember the 4 V's that we were talking about earlier, AIS data is a great example of these 4 V's of data. It will give you volume. It will give you millions of records that are created every day, every month. It gives you velocity. Why? Because each vessel actually broadcasts data at less than 5-minute intervals. It's going to give you variety because there's so much data that is being collected. It can be the vessel ID, it can be location, the speed of the data, the cost that is traveling, the vessel type, and more. Of course, there's still veracity. There is an element of uncertainty. And some results that are reported are actually quite uncertain. The additional good thing about AIS data is that there is actually an additional V. And that's what I'm actually going to introduce now. It's called variability. A single vessel actually can change between the different activity types and patterns of life as it moves through the sea. So what is the value of actually spatially analyzing this AIS data? Having correct and timely understanding of the data that can lead to effective and fast decisions for the vessels. It will actually help them safely navigate, avoid pirates, potentially give them chances to find high-yielding fishing spots, or locate other vessels in real time. And for organizations, it actually helps them gain visibility of vessels that are actually entering protected areas. It also helps them to identify shipping lane density or uncover any kind of anomalies that may indicate signs of distress. What we are going to do today is to actually take a look at the North Sea and the Baltic Sea area. This is an important waterway that actually connects the ports of the eastern shore of the Baltic Sea with the ports of the North Sea. What you actually see on the image there is the estimate of the cargo that is actually carried in 2014. Now, cargo includes grain, coal, steel, scrap, or timber. It has been estimated that the Baltic Sea region is actually one of the heaviest navigated seas in the world, with about 15% of the world's cargo transportation occurring here. However, given the large number of islands and the narrow straits in the region, it means that routes are actually quite difficult to navigate. And with ice cover in the winter, the Baltic Sea region is actually a high-risk area for incidents. So given this importance, right, we will actually try to understand what are the areas and where are the areas that congestion happens and whether they are affected by seasonality. So that's where you identify your problem. We will need to prepare the data. So what we have done is we have actually taken AIS data from the Danish Maritime Authority to try to identify the differences in pattern between seasons. Then we need to perform the analysis. We will actually use all the out-of-the-box tools that we were talking about earlier. So in this specific case, we will actually use the aggregate points and dynamically adjusting aggregations to show you the results. And of course, once you have actually done the analysis, you will need to review the information. By analyzing historical data regarding the vessel's identity, type, position, and speed, traffic intensity can actually be mapped in detail and provide actionable insights for maritime spatial planning and operational decisions on managing port and traffic operations. So I'll just hand it over to Tang so that he can actually show you the actual demonstration itself.
Thank you, Hui. So I'm using ArcGIS Pro. I'm logged into ArcGIS Enterprise. So if you can see, this ArcGIS Enterprise is enabled with Geoanalytics Server. So once it's enabled, when you click on the feature analysis, the Geoanalytics tool will automatically show up. These are all the tools that are available with Geoanalytics tool. And what I have here is the AIS for February data and the August data set. So what you can see is just like millions of points showing there, and you can't really make any sense out of it. And what we want to achieve is to gain insights. Is there a difference between these two seasons, namely winter and the summer? So what I can do is I can aggregate the points. So let's say I select February. So so when I aggregate them, I have options to select polygons or hexagon or bin size. So in this case, I select a bin, then I change it to a hexagon. And to standardize, I will aggregate into 20 kilometers. And for the time interval, will be 1 hour. So for the time repeat and the reference is optional. And you can also summarize your fields. Let's say you want to, there's some certain fields that you want to aggregate them. You can also include in the statistic. And once you run it, what you can get is the different points aggregate into the hex bin. So the beauty of using ArcGIS as a platform is that once you perform the analysis here, it's available in the web GIS platform where you can consume it on the web. And this is just one of the templates that are available in ArcGIS platform where you can compare two results side by side. Immediately when you compare two side by side, you can see during February, which is the winter period, the activity seems to be just around the harbor, and for the summer, there are more activities all around. And as we bring in other information, so I have this port size, which is categorized by their different size of the port. The larger it is, it represent it can handle larger vessels. And you can see those area with higher density, those are the ports with a smaller size. So it might suggest that during winter time, the smaller vessels cannot go out to the sea. And just to bring out, we aggregate these at a fixed scale. So as I zoom in, you can see the scale are still fixed. And starting 10.6.1, you can actually do this at scale. This is just one of the examples that I run on the same data set. So for example, if I zoom in further, as you can see, the different bin size, it will update. So I just zoom in, then it will rerun the aggregation. So how do I do that? So basically there are two methods. One is using Python API. The second one will be a bit manual where you need to go into the REST admin and the portal admin API to do that. So I will just show you the ArcGIS API for Python. So first thing, of course, most importantly, you need to connect to your ArcGIS Enterprise. So this is just a sample where you connect with your credential and then you look for your data set. So in this case, it will be the big data file share. I just registered the CSV files from the AIS. And then what is important in 10.6.1 is you enable the default aggregation to true. And then once you run the copy to data store, it will bring the big data file share data into the spatial temporal data store. So once I run, it will show all the messages. And finally, you just need to publish it as an image layer. So you just get the output, then publish it as a map image. And what you get is the output like this. And what's more importantly is that all this, because you know AIS, you can classify them by different ship types or different attributes. And this aggregation can be, you can also filter this image layer. So for example, now I want to set it to ship type, which is fishing. So once I apply the filter, it will just rerun the aggregation. Then you get to see only that satisfy this filter. So now you can focus on how to analyzing the data. So that will be end of my demo.
Thank you,
Pass
Teng.
it.
So basically what Teng has showed you, or what we have actually tried to show you in this very short session, is this. Essentially, the ArcGIS platform shows you that tools are actually available out of the box to run your big data analysis easily and at scale. So with the integrated platform capabilities, tools and workflows, they actually enable you to work more efficiently and to easily gain your capabilities for big data patterns and insights in both space, time, and scale. And you can do all of this analysis fast, because the idea behind all the tools that we were using is actually distributed compute capabilities of the entire platform. It is also actionable because it will actually enable organizations to visualize and react to larger amounts of data in a clearer and more meaningful way. What we have actually used and tried to show you is the analysis that was actually run on these couple of things. One is you need to set up your ArcGIS Enterprise-based deployment at 10.6.1, which would include the portal, the hosting server, your data stores, and the web adapters. And of course, to actually run the big data analysis, we actually needed to add a whole Geoanalytics server site with multiple Geoanalytics servers, and of course, the spatial temporal big data store. And to actually interact with all of these tools, like Tang showed just now, you can actually use your familiar desktop, which is ArcGIS Pro. Or if you are into coding, you can actually go straight away into using ArcGIS API for Python, or through the ArcGIS REST API itself. And of course, finally, thank you to the Danish Maritime Authority for providing us with the huge volumes of data that we were actually using for the analysis. And if you're actually interested to find out more information, these are the couple of resources that we have, which actually take you through the idea and what is the foundation of the ArcGIS Geoanalytics Server, what kind of geoanalytics tools are available inside the toolbox, if you remember the color-coded slide that I showed you just now. And of course, if you need to do geocoding at a massive scale, you can actually do it now. And again, some of the background to how all of this works is that everything is leveraging distributed computing. Of course, if you're also interested in training, there's actually a course online which you would be able to access if you're current on maintenance. So we have come to the end of our session.